This example comes out of section 10.2, which is products and quotients of functions. So this example is similar to the last ones, except for the first time we're asked for a quotient of two functions. So we've got two that we should be able to graph. F of x is just a parabola, g of x is just a straight line, but we're asked to do h of x equals g over f of x. So that's just a funny notation of saying g of x over f of x. So for f of x, if I wanted to draw this, I personally would probably write it in factored form, say x minus 4 times x minus 1, which helps me by telling me what the zeros are, 1, 2, 3, 4, and positive 1, and we have ourselves a y-intercept of 4, 3, 4, and so we can draw a fairly decent job of this parabola f. Now, g of x, a little bit different, is quite a simple function. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 12 is its y-intercept. It has a slope of 3. And so 1, 2, 3, 4, it's going to go something like that. So there's my function g. Now, h of x is the quotient of these two, so it's 3x minus 12 divided by x squared minus 5x plus 4. Now if that looks awfully familiar to you and looks like chapter 9, rational functions, that's because it's exactly what it is. We should then be able to graph this fairly well. First step we ran into in doing these was to factor everything that we could in a situation like this. And it gives me some insights into what this thing is going to look like. I will have a vertical asymptote at x equals 1. This function is undefined there, so an asymptote there. It also has a point of discontinuity at x equals 4. Now, my non-permissible values, as I just said, are 1 and 4. If I keep that in mind, this function really is just going to look like 3 over x minus 1 with a point of discontinuity. So this point of discontinuity is at x equals 4, and if I want to know what the y-coordinate is, I put 4 into this thing and I say 3 divided by 4 minus 1 just equals 1. So at 1, 2, 3, 4, comma 1, I'm going to have a point of discontinuity. This thing will have a horizontal asymptote at y equals 0. I'll have a a curve looking something like this, and something like this. So a nice review, I guess, of chapter 9 stuff. If they were to ask me anything about domain and range, the domain of this graph is that x can be anything except for x can't equal 1 or 4. And those two things show up differently on the graph, but they're still both not defined. They're non-permissible values for x. Now for y, my range is interesting in that y definitely can't equal 0 because that horizontal asymptote is there, but it also can't equal 1 because that's where that point of discontinuity is. So a little bit different than some of the other examples we've seen. An important thing to note here, since we have a second, is the zeros of the original graphs, f of x and g of x, this one had 1, 0 and 4, 0. And this one over here had also, coincidentally, 4, 0. When we found the quotient function, those zeros all will have some role in what that graph looks like. They're either, if they're in the bottom, they're going to be non-permissible values. So in this case it was g over f. So the zeros of f become non-permissible values and either then become vertical asymptotes or points of discontinuity. On g, the function that goes in the numerator, those zeros will either be zeros on the quotient function, or in the case of a function like this, where that is common with the denominator, you end up with that point of discontinuity. So this particular h of x function has no zeros, it has no x-intercepts because it does have a horizontal asymptote.